Too often for OEMs, the moment equipment leaves the factory, visibility disappears. Technicians often have to drive hours to a customer site, only to discover that the issue was something simple, like a configuration change, or worse, that they don't have the parts that they need, requiring a second visit. These delays frustrate customers and make it nearly impossible to scale service operations profitably. Here's an example of how the Connect Industrial Cloud Platform can help. Let's start with an asset reliability model in AVEVA Advanced Analytics, where we're tracking the model's output probability over time. This trend line represents the system's prediction that our failure event is going to occur. And you'll notice periods where the probability stays elevated for significant amounts of time. These plateaus are the model indicating sustained abnormal behavior. And all of the sharp spikes you see toward the right of the chart mark individual events where vibration, temperatures, or electrical load briefly shifted outside of normal operating bands. And this gives OEM reliability teams early insight into how and when an asset began drifting long before the customer notices anything. Behind this model, Connect gives OEM engineers full visibility into the features the model is using. The data wizard allows configuring the model to automatically filter out irrelevant or low-value properties so that the model stays clean and efficient. And on the right, you can see the full list of property inputs actually contributing to the reliability model. Bearing temperatures, sump temperature, inlet and output temperatures, vibration levels on multiple axes, and more. Everything required to build a strong predictive model. This transparency helps OEM engineers understand exactly which conditions drive failures in the field, and it turns customer runtime data into a continuous improvement loop. Now let's open the model artifacts, where we can inspect a specific anomaly that the model detected. Across the top, the historical anomaly breakdown shows when events occurred and how severe they were. Below that, we can drill into individual signals, like gearbox oil sump temperature, outdoor temperature, or inlet temperature, and see how they behaved leading up to and during the event. On the bottom, we have a statistical comparison, the normal distribution against the anomalous event distribution, with the green zone showing the ideal operating range. This view gives OEM engineers the data they need to explain exactly why a failure mode is developing and help them determine what intervention will prevent it. Now let's switch to the gas turbine monitoring dashboard inside Visualization Services. Up top, temperature probes show real-time values for key components: bearing temperatures, engine temperature, gearbox inlet and sump temperatures, and outdoor conditions. The status board in the center gives a rapid health snapshot with last values and trends for oil sump temperature, inlet temperature, frequency, voltage, and more. And on the right, we have hourly average output, maximums, and correlations like speed versus bearing temperature, which help operators understand exactly how electrical output relates to mechanical stress. OEM support engineers rely on this centralized, consistent view to diagnose issues and guide the customer before the situation escalates. Of course, none of this works without reliable data collection. Here in the Edge Data Store and Adapters view, we can see the health of every data collection device, all online and in a good state. These adapters are pulling data in real time from field equipment and control systems, supplemented by real-time data coming from AVEVA Historian, AVEVA MES, or AVEVA Pi System, which itself is collected and integrated into the cloud with no-code software installations. Engineers can perform long-term analysis across years of all of this collected operational data. Patterns like seasonal temperature shifts, load changes, and gradual bearing heating become obvious when visualized at this scale. This is the type of historical insight that OEMs rarely have access to, but with Connect, it becomes part of everyday service operations. With Connect, OEMs finally get continuous visibility into equipment performance. Advanced models detect degradation early, historical analytics explain why it's happening, and dashboards allow customers and OEMs to collaborate in real time. This transforms service from reactive firefighting into proactive reliability and gives OEMs a new way to to support customers with data-driven insights. Thanks to Connect.